Hello viewers, welcome to the next section, Stacks and Queues. Let's start with the first video that deals with the first type of limited access data structure, that is, stacks. To begin, let's talk about a stack. It is an easy to understand data structure and can be represented using the example of a pile of many plates, each placed on top of each other. This is the diagram of a stack with push and pop operations shown on the screen. The stack operates in exactly the same way. It allows you to add a new element at the top, the push operation, and get an element by removing it from the top, the pop operation. For this reason, a stack is consistent with the LIFO principle, which stands for last in, first out. Benefit from the features of stacks using the built-in generic stack class from the system.collections.generic namespace. It is worth mentioning three methods from this class, namely, push to insert an element at the top of the stack, pop to remove an element from the top of the stack and return it, peek to return an element from the top of the stack without removing it. It is high time to take a look at some examples. Let's go. For the first example, let's try to reverse a word using a stack. You can do this by iterating through characters that form a string, adding each at the top of the stack, and then removing all elements from the stack. At the end, you receive the reversed word, as shown in this diagram, which presents the process of reversing the marcin word. We will begin by adding this code snippet to the main method within the program class. In the first line, a new instance of the stack class is created. It is worth mentioning that in this scenario, the stack can contain only char elements. Then you iterate through all characters using the for each loop and insert each character at the top of the stack by calling the push method on the stack instance. The remaining part of the code consists of the while loop, which is executed until the stack is empty. This condition is checked using the count property. In each iteration, the top element is removed from the stack by calling pop and written in the console, using the writeStatic method of the console class. After running the code, navigate to the command prompt to view the result. The next example is a significantly more complex application of stacks. It is related to the mathematical game Tower of Hanoi. Let's start with the rules. The game requires 3 rods, onto which you can put disks. Each disk has a different size. At the beginning, all disks are placed on the first rod, forming the stack, ordered from the smallest at the top to the biggest at the bottom, as you can see in this image. Let's start with the example of moving only one disk. Such a case is trivial, and you just need to move a disk from the from rod to the to one without using the auxiliary rod. A bit more complex scenario is moving 2 disks. In such a case, you should move one disk from the from rod to the auxiliary one. Then you move the remaining disk from to to. At the end, you only need to move a disk from auxiliary to to. That's all. Now that you know the basic rules, let's proceed with the code. First, let's focus on the Hanoi Tower class, which contains the logic related to the game. Create a new class and name it as hanoitower.cs. Then make our class public by adding public before the class here. After that, we will add this part of the code from the code bundle. Here, the class contains 5 properties, storing the overall number of disks, the number of performed moves, and the representations for the 3 rods. That is, from, to, auxiliary. The move completed event is declared as well. It will be fired after each move to inform that the user interface should be refreshed. Therefore, you can show the proper content, illustrating the current state of the rods. Apart from the properties and the event, the class also has Constructor that we will add with this code snippet. The constructor takes only one parameter, namely the number of disks, and sets it as a value of the disks count property. Then, new instances of the stack class are created and references to them are stored in the from, to, and auxiliary properties. At the end, the for loop is used to create the necessary number of disks and to add elements from the first stack, from. It is worth noting that from, to, and auxiliary stacks only store integer values. Each integer value represents a size of a particular disk. Such data is crucial due to the rules of moving disks between rods. The operation of the algorithm is started by calling the start method with these two lines of code. The method just calls the move recursive method, passing the overall number of disks and references to 3 stacks as parameters. However, what happens in the move method? Let's look inside with this block of code. As you already know, this method is called recursively. For this reason, it is necessary to specify some exit conditions to prevent the method being called infinitely. In this case, the method will not call itself when the value of the disk's parameter is equal to or lower than 0. If such a value is greater than 0, then the move method is called, but the order of stacks is changed. Then the element is removed from the stack represented by the second parameter, from, and inserted at the top of the stack represented by the third parameter, to. Here, the number of moves count, is incremented and the move completed event is fired. At the end, the move method is called again with another configuration of rod order. By calling this method several times, the disks will be moved from the first, from, to the second, to rod. The operations performed in the move method are consistent with the description of the problem of moving disks between rods, as explained in the introduction to this example. After the class with the logic regarding the Tower of Hanoi game is created, let's see how to create the user interface that allows you to present the following moves of the algorithm. So, we will move to the program class and these 3 lines of code. First, 2 constants are declared, namely with the overall number of disks, disks_count set to 10, and the delay, in milliseconds, between 2 following moves of the algorithm, delay_ms set to 250. Moreover, the private static field is declared, which represents the number of characters used to present a single rod, _column size set to 30. After that, we will execute the main method in the program class by adding this code snippet. First, the width of a single column that is representing a rod is calculated with the use of the auxiliary getDiskWidth method. Then a new instance of the Hanoi Tower class is created, and it is indicated that the algorithm visualize method will be called when the move completed event is fired. Next, the aforementioned algorithm visualize method is called to present the initial state of the game. Finally, the start method is called to start moving disks between rods. Now let's include algorithm visualize method by adding this code snippet. The visualization of the algorithm should present the current state of the game in the console. Thus, whenever a refresh is necessary, the algorithm_visualize method clears the current content of the console by calling the clear method. Then it calls the Initialized visualization method to prepare the jagged array with content that should be written in the console. Such content consists of 3 columns, which are prepared by calling the prepareColumn method. After calling it, the visualization array contains data that should just be presented in the console, without any additional transformations. To do so, the drawVisualization method is called. Of course, the header and additional explanations are written to the console using the writeLine method of the console class. The important role is performed by the last line of code, where the sleep method of the thread class from the system.threading namespace is called. It suspends the current thread for delay_ms milliseconds. Such a line is added to present the following steps of the algorithm in a convenient way for the user. Let's take a look at the code for the Initialized visualization method. The method declares the jagged array with the number of rows equal to the overall number of disks, the disks count property. The number of columns is equal to the value of the column size field multiplied by 3 to present 3 rods. Within the method, 2 for loops are used to iterate through the following rows, the first for loop, and through all columns, the second for loop. By default, all elements in the array are initialized with single spaces. Finally, the initialized array is returned. To fill the aforementioned jagged array with the illustration of the current state of the rod, we need to call the prepareColumn method. So we will add this code snippet as you can see here. First, the left margin is calculated to add data in the correct section within the overall array. That is, within the correct range of columns. However, the main part of the method is the for loop, where the number of iterations is equal to the number of disks located in the given stack. In each iteration, the size of the current disk is read using the extension method from the system.linQ namespace. Next, you calculate an index of a row, where the disk should be shown, as well as the start and end indices for the columns. Finally, the for loop is used to insert the equals to sign in proper locations in the jagged array, passed as the visualization parameter. The next visualization-related method is drawVisualization. For that, we will use these few lines of code. The method just iterates through all elements of the jagged array passed as the visualization parameter and calls the writeLine method for each array located within the jagged array. As a result, data located in the whole array are written to the console. One of the auxiliary methods is center. Let's add the related code from the code bundle. Its aim is to add additional spaces before and after the text, passed as the parameter to center the text in the column. Another method is getDiskWidth, which just returns the number of characters necessary to present the disk with the size specified by the parameter. Let's add the related code here in the program class. As we have already added the necessary code to run the application, which will present the following moves in the Tower of Hanoi mathematical game. Let's launch the application and see it in action. To view the result, we will need to switch to the command prompt. Just after starting the program, you will see a this result similar to this, where all disks are located in the first rod, from. In the next step, the smallest disk is moved from the top of the first rod, from, to the top of the third rod, auxiliary, as you can see here. While making many other moves, you can see how disks are moved between all three rods. One of the intermediate states is shown here. When the necessary moves are completed, all disks are moved from the first disk, from, to the second one, to. The final result is presented in the following illustration. Finally, it is worth mentioning the number of moves necessary to complete the Tower of Hanoi game. In the case of 10 disks, the number of moves is 1023. If you only use 3 disks, the number of moves is only 7. Generally speaking, the number of moves can be calculated with the formula 2n-1, where n is the number of disks. That's all. In this video, you have learned the first limited access data structure, namely a stack.